If you think Jupiter is massive, think again. Yes, Jupiter is already a monster, large enough to fit more than 1,300 Earths inside it, the undisputed king of our solar system, a world of endless storms, violent winds, and swirling clouds. But far beyond our sun, astronomers have discovered something that makes even Jupiter look small. A planet so huge, yet so unbelievably light, that it almost feels impossible. Before we reach that cosmic giant, let's begin at home and climb step by step into the realm of giants. Earth versus Jupiter. Earth has a radius of about 6,000 kilometers, big enough to hold oceans, mountains, and life itself. But beside Jupiter, Earth is insignificant. Jupiter is more than 11 times wider than Earth. You could pack 1,300 Earths inside it and still have room left over. It has no solid surface, only layers of gas and pressure beyond imagination. Its storms can rage for centuries, and the Great Red Spot, a single hurricane so massive 3 Earths could fit inside it, has been spinning for over 300 years. Within our solar system, Jupiter is the first true giant. But what if there's a world so extreme that Jupiter looks like a marble next to a beach ball? Meet HAT-P-67b. Discovered in 2017, HAT-P-67b is a gas giant located roughly 1,200 light-years away in the constellation Hercules. Its size is staggering. This planet is about 2.1 times the radius of Jupiter, stretching nearly 150,000 kilometers wide. But here's the twist. Despite its enormous size, HAT-P-67b has less than half the mass of Jupiter, only 0.34 Jupiter masses. That means it's gigantic, yet incredibly light. Astronomers call it a puffy planet. In theory, if you could place HAT-P-67b into an ocean large enough, it would float. It is the largest planet ever discovered by radius, yet one of the least dense objects we've ever seen orbiting a star. So how can something this massive be so light? A planet too close to death, HAT-P-67b, orbits an F-type star called HAT-P-67, a star hotter and brighter than our sun. The planet is dangerously close, just 0.065 astronomical units away, about 10 million kilometers. That's nearly 6 times closer than Mercury is to the sun. Because of this, HAT-P-67b completes one full orbit in less than 5 days. A year on this planet lasts shorter than a work week on Earth. Its star shines 12 times brighter than the sun and is more than twice as large. Being this close is almost a death sentence. The planet is boiling, stretching, and slowly being torn apart by heat and radiation. The inflation effect planets like HAT-P-67b belong to a rare group known as hot Jupiters, gas giants that orbit extremely close to their stars. That proximity floods them with energy, heating their atmospheres until they expand dramatically. For HAT-P-67b, temperatures reach nearly 1,900 Kelvin, about 1,630 degrees, hot enough to melt metal. The star's radiation ionizes the gas, stripping electrons and supercharging the atmosphere. The planet swells like a balloon, puffed up far beyond what physics says should be stable. Astronomers call this the hot Jupiter inflation effect. But HAT-P-67b takes it to the extreme. A giant that's evaporating this planet isn't just inflated, it's evaporating. Observations show it loses around 10 million tons of gas every second. Hydrogen and helium stream away, forming a massive cloud around the planet. That cloud stretches like a comet's tail, reaching 6 times the size of Jupiter. That's not just big, that's unreal. The fragile giant, imagine it. A planet over 150,000 kilometers wide, lighter than Saturn, with a year shorter than 5 days. Surface temperatures above 1,600 degrees. Winds faster than sound. If it orbited our sun, its outer edges would nearly reach the orbit of Mars. Despite being almost the size of a small star, it's so fluffy that, in theory, it could float in water. But this giant is unstable. Every second, HAT-P-67b is losing itself to space, slowly shrinking, fading, and eventually, it's expanding. Star will consume it entirely. In a few 100 million years, it will be gone, a giant doomed by its own size. Why it matters: HAT-P-67b blurs the line between planet and star. Too big to be normal, too light to ignite. Its existence forces scientists to rethink how planets form. It likely began far from its star, then drifted inward, until the heat began tearing it apart. Its story is a warning written in gas and fire. Size does not always mean strength. This planet is massive yet fragile, burning yet dissolving, like a balloon hovering too close to a flame. HAT-P-67b proves that under extreme conditions, a planet can grow so large that it begins to fall apart. It floats where no world should. It shines even as it disappears. Because the universe never runs out of surprises. And HAT-P-67b is one of the strangest worlds we've ever found. So what happens when something grows too large, too fast, and too close to danger? HAT-P-67b gives us the answer. From a distance, it looks powerful, enormous, unstoppable. But power can be deceptive. This planet is not held together by strength but by balance, and that balance is failing. Every second, its star strips away its atmosphere. Every second, part of this giant vanishes into space. Not with an explosion, not with drama, but slowly, silently. A reminder that destruction doesn't always arrive suddenly. Sometimes it happens one breath at a time. HAT-P-67b challenges everything we assumed about planets. It shows us that size does not guarantee survival, that being bigger doesn't always mean being stronger. In fact, sometimes being too big is the very thing that causes the fall. Astronomers believe this planet was not born here. It likely formed far away, in a colder, safer region of space. But gravity pulled it inward, closer, hotter, until the star it orbited began to erase it. And now, we are witnessing a planet in its final chapter. This isn't just a story about a distant world. It's a lesson written across the cosmos, because the universe is not gentle with extremes. It rewards balance and punishes excess. HAT-P-67b floats on the edge between existence and disappearance. Too large to ignore, too fragile to last. One day, its atmosphere will thin beyond recovery, its swollen size will collapse, and eventually, it will be swallowed by the very star that made it shine. No monuments, no remains, just gas, light, and memory. And yet, its brief existence matters. Because every strange world we discover forces us to rethink what is possible. It reminds us that the universe is still full of surprises, worlds that refuse to fit our rules. HAT-P-67b is one of them, a giant that floats, a planet that evaporates, a reminder that even in space, nothing lasts forever.